Systems of linear equations. A system of linear equations is when we graph one or more linear equations. The solution of a system of linear equations is the point where the two lines cross. If the equations have the same slope, then the lines will not cross and there will be no solution. So now I'm going to show you a couple of examples of how to solve these problems by graphing. So here we have a system of equations and we want to solve it by graphing the system on the coordinate plane. So just like last time, we're always going to start by graphing our y coordinate, our y-intercept, I should say. So for this first equation, we know that our y-intercept is 4, and we know that our slope is -1, which is, of course, -1 divided by 1. And so when I graph this first line, I start by graphing our y-intercept of 4, and then going up 1 and over 1 to the left to graph my slope. Now, going to graph this second line, and in the second line, my y-intercept is -5, and my slope is 2, which can be written as 2 over 1. And so when I graph this, I'm going to first start by graphing the y-intercept of -5, and then doing my rise and run. So my rise is +2, and my run is 1. And now I've graphed both lines, and I can find the solution. And again, the solution is where these two lines intersect. It's a coordinate point. And so that coordinate point looks like it is 3, 1. And so that point is my solution to the system. All right, let's try another. Here's a new system of equations. My first line is y equals 1 over 4 times x plus 5, and my second line is y equals -x minus 5. And so if I'm graphing my first line, I know that the y-intercept is 5, and my slope is 1 over 4. For my second line, I know that my y-intercept b is -5, and my slope is -1, which can be written as -1 over 1. So now I can graph both of these lines by following the same steps as before. First line has a y-intercept of 5, so I put a point there, and it has a rise of 1 and a run of 4. So there's my first line. And now I want to graph the second line. So the second line has a y-intercept of -5, so I'll click that first. And it has a slope of -1, so I'm going to rise 1 and run 1 to the left so that it has a negative slope. And now we can easily find the solution. It's this coordinate point, which looks like -8, 3. Let's see, -8, 3. That is my solution. Let's do one more example. In this problem, the first line that we have to graph is y equals -x plus 3. So I know that my y-intercept is going to be +3, and my slope m is going to be -1, which again can be written as -1 over 1. Anytime we have an integer or a whole number, we can write it as a fraction. And I know that for my second line, my y-intercept is -2, and the slope m is 3 over 2. So when I go to graph this, the first thing I'll do is graph the y-intercept of my first line, which was 3, and then count my rise and my run. So I'm going to go up 1 and over 1 to the left so that this has a slope of -1. For my second line, my y-intercept is at -2. And then when I count my rise of 3 and my run of 2, I will go up 3 and then over 2. And right there is where these two lines intersect, which means the solution must be 2, 1. So that point 2, 1 is where the lines intersect, which means it must be my solution.